folks. Welcome to Land Tamer String. Yeah, we're going to do another lab today. I was reading some material about Ospf, the Ospf redistribution, and thought, you know what, I do need to lab this. This is just a random photo found on Flickr, Creative Commons license, cool stuff. But yeah, I've been getting some good study done, and glad to see Bashy Mashy in the chat there. And wow, we get a blind hacker's now auto-hosting me again. That's great. Thank you, blind hacker. I appreciate it. That should now, the auto-host, it's supposed to give an alert. I did not see an alert come up, but anyway, all right, we'll figure that out. Yeah, so this topic is going to be, well, first of all, about rabbit holes. Just a thought on that is one piece of advice I got from, someone that I really respect when I was trying to get some mentoring in regards to, getting past the next phase and the process here of, I'm planning for the written. I got 72 days to go or so, 71 days. So one thing that's important to do is to not go too far down rabbit holes, was the advice given, which I really agree with. And I think you'll find anyone in the community, particularly those who have already attained their CCIE, that's very important. So I agree with that, and I'm trying to, I've done a few labs the last few sessions, study sessions I've had. I've tried to keep them brief though, and I've tried to keep them just the sole purpose is I'm not trying to complete the lab, I'm not working on speed, I'm not trying to complete a lab exercise, see if I got the right answer. I'm not trying to do that at all. Right now I'm just trying to grasp the principles, grasp the information. I'm trying to learn. Right, and learn not just for speed, but learn with the view to covering the blueprint topics better. So that's what I'm working on now. As many of you may know, I did create out of the Google Drive share a while back. I created a redistribution chart, and that is under. I can actually put the link here. Many of you may have it already, but this is all available to everyone. And under, I think it's reference sheets. Yeah, I created a new redistribution chart, and this has certain caveats with redistributing one dynamic routing protocol into the other. And it was, I think, Tony E. who Show IP Interface Brief brought up. You should also try to cover routing, add Ospf to Ospf, EIGRP to EIGRP. So good point. And so I'm trying to in the interest of completing this form, I came across this article, Cisco doc, which is here, and it covers it in detail. So I'm going to copy that here into the chat, and it's a very in-depth article. And I was going through it, reading it. I'm like, okay, that makes sense. But really, I want to just lab this up a little bit here. So that's what I'm going to do for the rest of the evening is work on this. So here we go. The article, let's open it up. I've already got it open here somewhere. Yep. All right. This is a very well-written tech note, I have to say. There are some very good tech notes out there. And this one in particular is good. It's updated January 19th, so somewhat recent. But the subheadings are, why did redistribute between two Ospf processes? Great question. Immediately one I had, why would you ever do that? And I posted on Instagram about this. And after it goes over why, it comes into here sort of some different redistribution methodologies you can use. And they have a proposed solution. So here's how you could do it. Here's how we recommend you do it. So I thought it was good so far, but I just wanted to go over this and see if I could explain it. So why redistribute between two Ospf processes? First of all, it says, and this is what I highlight on Instagram, Ospf between different processes, redistribution between different processes is difficult. Okay, warning. It is difficult. You thought redistribution between one, Ospf and EIGRP could get dicey. This is going to be difficult, right? This document highlights some changes introduced, and special measures are necessary for the proper operation of the network. So thank you for the warning. I appreciate it. Let's see what kind of damage we can do here. Why do it? Well, there can be a few reasons mentioned here. You want to filter an OSPF route from part of the domain. We all know how OSPF is configured. You know, it has a link state database that is shared. The database has to be synced within an area in particular. So it's not easy to, if you want to hide, for whatever reason, if you want to hide part of the topology, some of the prefix, some of the links from another router in the OSPF domain, or including inside that area in particular, you've got issues, right? That might be a reason to do it. Just separate this area into two different OSPF processes and do redistribution to filter it the way you want it. You want to separate different OSPF domains, or you're migrating between separate domains, right? So let's say you got some sort of merger, both running OSPF, small networks, you connect them together, and you want to do some redistribution so that they can start to talk to each other, right? There might be some use cases. Of course, there are other technologies you can use to do that besides OSPF to OSPF redistribution, but it's going to mention some of these. First of all, one of the limitations is, as it mentions here, filtering the OSPF route. Much easier to do, for example, in EIGRP, because EIGRP does not, it basically forms an adjacency with directly connected neighbors. So with each connection to each neighbor, you can do filtering, you have a lot more control also with BGP, right? You have a lot more control about what you can filter between routers. But basically what it says here, local filtering on a router, which is not considered to be actual route filtering. This is normally accomplished with a distribute list command under router OSPF. In OSPF IP prefix with an area are not exchanged directly between routers. They're part of the link state advertisement that also announces the topology of the network. Therefore, there is no way to filter routes within an area. That's your big challenge, right? So that is one potential use case. One solution would be to use a different process and filter the desired routes on the redistributed routers. However, this actually separates the area into two domains. And it's telling you here, okay, you can do this, okay? It's not out of the realm of impossibility, but a better design would be to separate the area into two different areas, because you can, in OSPF, do route filtering between areas when you're filtering the LSA type 3s, right? Which in the INE workbook, there's actually a lab for this. Let me pull up the workbook here. I don't actually have, I've been so used, I'm using Safari here. Typically I try to keep, and I haven't done a lab out of the workbook so long, I don't even think I have the link anymore here, so we'll just log into it here using. Anyway, point is, I won't bring it up, but point is, INE has a lab in the Advanced Technologies workbook that does some of this inter-area route filtering. All right, so inter-area routes in OSPF, all routers within an area have the exact same topology. An area has no knowledge of the topology of another area, therefore relies on information announced by the ABR, of course. So the information advertised inside an area by an ABR is actually every features that are learned from remote areas or that are calculated for other attached areas. So this is the OSPF. You can go to this link. That's a pretty basic link, and that's how you can filter between areas. Now, external route filtering, because external routes are advertised as type 5s and are flooded domain-wide, except, of course, in the stubs and not so stubbies, there's currently no way to filter a type 5 LSA. So let's take some notes here. And who knows, this could become a blog or something one day. Let's see, what do we want to use for a tool? Too much stuff open. Apologize, folks. Apparently the music didn't work out. Still working on those details there. Actually, let me do text edit, because I'm probably going to do this as a GitHub gist, or Yeah, it'll probably end up being a GitHub gist or a blog post. But Ospf route filtering, we can say intra-area routes cannot filter using the same process. Inter-area routes, you can filter using LSA type 3 filtering feature. And external routes cannot filter using the same process. So at least in case number 1 and in case number 3, you might be able to justify doing Ospf to Ospf redistribution, right? So keep different Ospf domains separate. It is seen as a common practice to use different Ospf process in order to separate different IP routing domains, either for administrative purposes. Okay, so think about that. When you have, I'm not sure what type of network this would be, but there are a lot of different types of networks out there, folks. I have seen actually very large area zeros in production, like very large Ospf area zeros, including, leaving the, WAN link connections forming area 0, which I so would not recommend, but I've seen it done, all right? So yes, you might have a scenario like that. Maybe you have a merger, maybe you have different departments, maybe you have different networking groups, and while you want to have the same, this typical area, you say, okay, I'm fine sharing all the routes, the links inside this area, but I have network team A and I have network team B. And network team B needs to be able to control this sort of domain, and network team A needs to be able to control this. So for administrative reasons, you might have a scenario where you need to sort of separate the control. What else is mentioned here? It should be noted, however, that instability in one domain could affect the other domain. So obviously, if you're redistributing between Ospf domains, and there's fluctuation or there are network problems in one domain, obviously those are going to impact the other domain as well. You're not necessarily, just because you split a domain into two, it doesn't mean that you are necessarily adding stability, right? And as it mentions here, if you have that kind of issue, a better design choice is to use BGP. So if you're looking for stability, BGP has the dampening features, right? So let's make a note about that to separate Ospf, where two Ospf domains are unstable. The better design is to implement BGP with route dampening, right? Okay, redistributing between different Ospf processes. As I mentioned previously, there can be an alternate solution, but if you insist, we're going to proceed to show you kind of how to do it, right? So the Ospf route selection rule, we know what that is, right? We always want to select intra-area routes over inter, and intra and inter over external. There are always caveats to that and exceptions and changes, things you can do. But as it's mentioned here, there is no preference between external routes from one process compared to internal routes of the other process. Let's read that again. In other words, this rule should apply to routes learned via the same process. Okay, so in other words, some of these bets are off. We kind of know how that selection route preference works inside of the same Ospf process. When you introduce another process, however, some of those rules may change, right? In other words, there's no preference between the external routes of one process compared to internal routes of the other process. And it's going to illustrate this in a minute. The preference rule between a given OSPF and any other process, be it OSPF or another, should follow the administrative distance rule. However, because different OSPF processes will have the same administrative distance by default, OSPF distance should be configured explicitly for different OSPF processes in order to achieve this desired behavior. So if you have a single router, and I have OSPF domain 1, I have OSPF domain 2, and both of these, let's say there's a link here. Well, actually, I'll let this get into it. Basically, if I'm router A, I'm going to see external routes for both domain 1 and domain 2. They may have been learned, it may be a single prefix, right, that is only accessible, or that may be, accessible via both domains. But how am I going to be able to dictate a preference of either using OSPF domain 1 or 2? By default, I won't be, because they're going to have the same administrative distance, right? So when there's a single redistribution point, all exchange between the domain occurs at a single point, and there's no way that a redistribution loop can form. This is pretty safe, right? And this is in general with kind of any routing protocol redistribution. Where you get into trouble is when you have this, right? And you have mutual redistribution by both. This is where you can start to get churn and things can get very interesting, right? And basically the command we see here is redistribute OSPF2 subnet. You just tell it redistribute the process and then subnets, right? Now this is where it gets tricky, and I think I want to go ahead and try to lab this. Hey Banner, what's going on? Yo, Banner's in the house. Good to have you, my friend. Hope you're having a good Sunday. I know I said that already, but we're doing a little more labbing. So let me shove this over here and get some lab stuff going here. All right, I got Eve. It's already loaded up. By the way, EVE works better in Chrome, just because there's a plugin for Chrome that allows you to copy paste if you're using the HTML5 console, right? I don't do that. Okay. We're going to go HTML5 console here. And we're going to build out our, I don't have a lab for this, right? So I'm just going to build out my own topology. I'm going to close this lab, and we're going to do a new lab. OSPF to OSPF redistribution. OSPF to OSPF redistribution testing using Cisco troubleshooting notes. And I want to put the reference here. This is good. I'm trying to get used to this. I'm going to be working a lot more with DevOps. And, I'm using Git and things like that. You notice with Git, whenever you do create new content, you do a commit, for example, you have to enter in a comment, which is good. I need to get used to doing that. So we're going to test. We're going to build a basic OSPF topology with multiple processes. And what we'll do here is, I think what we got, 1, 2, 3. Yeah, what we might do is just for fun, we'll put in 4 routers, because I got a feeling that we're going to do some external redistribution. Well, we can use a loopback. That's fine. So we'll do routers A, B, and C to start. We can add more as we need them. Add an object. Here we go. Node. I'm still getting used to Eve and G. I've been, a viral user for so long. And we'll go ahead and add 3. R is a prefix. And these are fine. We're going to say router 1, router 2, and router 3. And let's take a look at the links here. I like this too. Sometimes you got to make your own labs. right? So often in labbing on this channel, it's been me going through a workbook and off to the side kind of thing, but it's fun to kind of get to create your own lab. All right, it doesn't, so we're going to have to, okay, interesting. So we need a fourth, actually. And they have the proposed solution here. Let's see what networks they're using. All right, it doesn't really say, so we're going to make some up, right? So let's add a fourth router. Actually, can I duplicate? Can I copy paste? Nope. It was a thought. And this is going to be R4. Okay, we're going to put him down here for now. And we're going to go ahead and look at what links we might need. So this area is going to be connected. I think we're going to just put some networks here. Let's do 2 networks. That may be the easiest way to sort of accomplish this here. Yeah. And let's link these bad boys up. And GI00, yep. Let's do the same GI00. And yeah, this is going to be some nasty redistribution, I have to say. And this is going to be GI01. 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 Okay, 1, 2, 3, 4. Is that right? Oh, A, B, C, D. Ah, that's fine. All right, let's start up our routers. And let's look at, okay, this is pretty simple. We're fine here. We're good. 2 redistribution points is more complicated when there are 2 points of redistribution. You don't say. Now, if redistribution is done in both points of a network, I hope you guys can see this okay. I want to make that a little bigger. And I'm going to move this because actually we can probably close our agenda. And we can move that. Okay. It's more complicated too. If the redistribution is done in both points of the network without any special care, there might be unexpected results. Okay, folks, let's get on our, white gloves. We're going to give some very special care to this Ospf network, okay? Can we do that? Yeah, I think we can do that. We're going to call it white glove networking. How's that? That's a new meme, right? Or that's a new... That's a good emote idea for the future. All right, consider the next topology where router A and B redistribute mutually between both domains. This configuration does not work, as will be demonstrated later in this section. Okay. Given a network N in domain 1, router A and B learn network N as an internal route in domain 1. Right. Because they redistribute process 1 into process 2, the same network N is learned in domain 2 as an external route. Now, in each router, the internal network learned via one process competes against the external network of another process. Previously mentioned, there is no preference rule between different processes. Therefore, the result would be indeterministic, as both processes have the same administrative distance. Note, this could lead to a constant injection and withdrawal of a type 5 from one process to another. Okay, so we'll probably have some oscillation, right? Before this bug, last process to make a SPF would have 1, and the process would overwrite other routes in routing table. Now, for routers installed via one process is not overwritten by another, with same administrator domain unless the router is first deleted. Okay. So let's demonstrate this. Let's configure some networks here. And I think we could get rid of that one. And let's open some windows. See, router 1, router 3, router 2. Let's put 3 right here, 2 there, and 4 over here. Put them order top. No. No here. Okay, we'll wait for those to, the images to finish loading. I think what we'll do here is just like, I don't know. We'll do a loop back here, like 192.168. And we'll do 10.1 over here. This will be 10.1. This will be 10.2. And we'll do a loop back here. Why don't we do that? So let's do this in... Let's go ahead and do it in quote-unquote Notepad here. So on router 3... Boy, I'm so out of the habit of doing labs. We're going to say interface L0, IP address 192.168.3.1. And we're going to say interface GI0, 0, IP address 10.1.1.3. No shut. And we're going to do router OSPF 1. Let's see, which one is 1? I'm assuming this is going to be OSPF domain 1, yeah. Router OSPF 1, network 0.0.0, 0.0.0.0, area 0. Okay, and then router 1. We're going to say... we're not worried about a loop back here, although that does kind of help our OSPF router ID, but that doesn't really matter here. So we're going to say 10.1.1.1, and then on router 2, we're going to do 10.1.1.2. Okay. Good. So that is OSPF process 1. Then what we're going to do is we're going to say, now how is router or OSPF process 2 set up? Okay, so I think what we have here is on GI01, yeah, we need to do that. Interface GI01, IP address 10.1.2.1. No shut, router OSPF2, network. You know, for grins, let's do this. Network 10.1.1.0. Area 0. And then for router 2, or routing process number 2, 10.1.2.0. How's that? All right. So let's come back here, redo this. And on router 2, we're going to say 10.1.1.2, 10.1.2.2. All right, and then router 4, we're going to do something like this. We're going to redistribute all the links, and we're going to have a loopback as well. Actually, let's pull this one. And this one's going to be 192.168.4.1. And this is going to be 10.1.2.4. And router Ospf1 redistribute everything. Okay. That's what I want. All right, so let's punch in these configs and see what we get. Well, let's do this just for our own sanity here. Host name R3, host name R1. All right. Control V. Come on, work. I really need this extension to be working. Maybe it's not under guest. That's why. Shoot. All right, well, login as me. That's fine. Oh, man. See if that works. Ooh, it does. That's cool. I like that. Learning as I go here on Eve. That's pretty cool. Yeah, it's going to make me log in. That's cool. That's fine. So what we're going to do here, copy paste. Always allow. Okay. What does it want on the Mac? Okay, there we go. Just right click. Nice. Okay, router 1. Oh, these are out of order. That says, this is router 3 actually. Let's close that. Let's check these now. I'm wondering. Well, we thought that would be efficient. This should be router 3. All right. He's probably going to gripe about that, but that's fine. Router 3. This will be router 1. And this should change everything here. Let's do, first of all, take that loop back out. What did I get wrong here? Network something. Do I have it in here twice? Oh, I do. Okay. All right, that's router 1. Let's go over here to router 2. And we should be getting some adjacencies here. Okay. So let's do show IP Ospf. No, Ospf neighbors. Show IP interface brief. It may not have converged yet. Oh, this is supposed to be 10. This is supposed to be 0, 1. Since I did the copy paste here, that kind of messed up. There we go. All right, we're in DR other. Now we got full. Remember, even though I have process 1 here, that doesn't matter. Process is something locally significant only. Right? So that looks good. So now if I do show IP route. All right, I've learned about 10.1.2. I have not learned about, all right, we have not done redistribution yet. So let's say, for example, this is a scenario where we could have made this one domain, and this could have been area 0, this could have been area 1, and we would have learned all routes, right? But for whatever reason, we decided that we need to split this into 2 domains based on one of the other criteria mentioned before, right? So this is all area 0. This is all we have. We have not learned any routes. Once we do redistribution, however, we should learn the other routes. Let's look over here. Duplicate router ID. Oh, yeah, because, yeah. Router, OSPF1, router ID. Let's just make it 10.1.2.2. Yeah, I didn't think about this problem. 10.1.1.1. And then router OSPF2, router ID 10.1.2.1. Clear IP OSPF1. Process. Clear IP OSPF2 process. It didn't ask me to do that, I don't think, for 2, but I'm doing it anyway. Yeah, because it at one time had the same loopback that router 3 had, so hence the issue. So now if we do here on router 1, let's see what we've got. Show IP OSPF. No, let's do show IP route. Okay, so since he's in 2 different OSPF processes, we have successfully learned of 10.1.1.0 and 10.1.2.0. We've also learned about router 3's loopback. 1.2 wants to say 3.0. We have not learned about router 4's, and that may be the flapping. 1.2 wants to on gigabit 0.1 from loading to full. Okay, it's because I reset the process, right? So now he should. All right, interesting. Show IP route OSPF. So we're not learning that, although let's see what we got on router 2. Okay, now this is interesting, right? Because we've got, if you do, this can be confusing. If you look at the show IP OSPF neighbors, it's showing the same neighbor twice, right? And that, of course, is because the we have 2 different process IDs. So can we say per process here? Show IP OSPF. Okay, here we go. 1 neighbors and 2 neighbors. Yeah, okay. So that's what we expect right now. What do we have for routing here? Show IP route. Okay, he's got both of them. Router 1 does not. Maybe this is related to the issue that we're talking about. So why would he not learn? We haven't even done redistribution yet. So far, right now we have, pretty normal network. Show IP DR other DR. Okay, yeah. 10.1.2.1 and 10.1.2.2. Show run section Osp. Are we advertising our... Well, yeah, we are, because router 2 knows about it. Uh-oh, process 1 flushes LSA ID type 2 advertises in area 0. Haha. Hey guys, we've got a flood war. We've got a flood war on our hands. It's time to mount up. Shots have been fired. I took a screenshot of that, man. That's going on my Instagram. Flood war, process 1 flushes. Now let's look at what it's flushing here. A type 2 advertising router 10.1.2.2 in area 0. So let's look at show IP Ospf 1 database network. Okay, that looks right. Now it's showing me, interestingly enough, this is for process ID number 1. And router 3 is a designated router on this segment. And we have 3 links in this part of the graph, which is what we expect. And over here we have router 2 is the designated router. And we have 3 links. Now this should be 10.1.2.1. Process 2 re-originates LSA ID 10.1.2.2. Which one did it withdraw? Right, let's make sure our configuration is correct here on these interfaces. Show run interface GI01. That's correct. Okay. Show IP Ospf process 1 database. Database network. 3.1, 1.1. I don't know why. I guess it's... Even though I'm telling it, I only want process ID number 1. Let me look at my Ospf configuration. I don't want to advertise the GI01 to the other area. Oh, this is why. Okay. Yeah, we got to take that out. That is messing up everything. So I should be able to... Yeah. Clear... Process. Yes. That's why. Okay. Clear IP Ospf1 process. And we need to do it on all these routers in area 1. Clear IP Ospf1 process. Yeah, that's why everything was messed up. Hey, we got a new follow. I did not see that follow come through. Thank you, IPv667. I love it. Man, I got to check this OBS thing here. Yeah, it's not announcing the new follower. I don't know why that is. Streambox. Streamlabs alerts is there. Anyway, thank you very much, IPv667. Appreciate the follow. Show IP. All right, let's go back over here, router 1. Show IP OSPF 1 database network. Okay, this is address of designated router. Address of designated router 10.1.2.2. Yeah, something is still not. 10.1.1.1 should not be. Does it look different with process 2? Nothing. Interesting, guys. You see that? So process 2 is running. Router ID. Strange. So I'm assuming what it's doing is it's combining the databases somehow. This looks right. This does not look right. This should be 10.1.2.1 and 10.1.2.2. Oh, because that's the router ID. Okay, I get it. That's how that works. All right, interesting. So let's get to our. We're still getting a flood war here. And let's make it even worse. We're going to redistribute. We're going to do mutual redistribution. So we're going to go router OSPF 1, redistribute OSPF 2 subnets. Router OSPF, redistribute OSPF 1 subnets. I just picture the routers going nuts right now. Router OSPF 1, redistribute OSPF 2 subnets. Router OSPF 2, redistribute. So we're already going a little nuts here. You know what? I think what we want to do with this process is also redistribute. Let's create interface loopback 1. IP address 192.168.33.1. And we should redo this process here because show run section OSPF. Instead of the all balls here, let's do network 10.1.1.0 and network 192.168.3.0. Node network 0.0.0.0. And let's clear IP OSPF. And then what we want to do is redistribute. Router OSPF 1, redistribute. Connected. We'll just do that. So now it should take the new 192.168.33, and that should show up as an external route. Let's do the same over here on router 4. Interface L1, IP address 192.168.44.1, and router OSPF 1, no network. Well, let's do network 10.1.2.0. And network 192.168.4.0. And no network 0.0.0.0. do show run. And we will do redistribute, can't spell, connected subnets. Clear IP OSPF 1 process. Let's do the same on all these. Let's go back to router 1. And clear IP OSPF 2 process. I'm getting good at clearing that process, buddy. Yeah, we made it. Hey, this plus that, man. You know, this plus that, you inspired me to do a lab earlier today. I know you saw that. And, man, I wish I had a better explanation for the GARP. I've been seeing a few little interesting things here in the lab. You know, I hate to blame the lab for any issues. I try to use that as sort of a last resort because more often than not, it's not really a problem with the lab. It's a problem with the operator. All right, so let's do now. All right, we're still kind of converging. Let's look at Lisa router 3. Show IP OSPF. Show IP route. Okay, good. So now we're seeing this as a 20, right? So it's going to be an E type 2. Show IP OSPF database external. Look, now we're learning the 10.1.2s, right? Because of the redistribution. But there's our loopback. It is an external, right? Interesting. So here's what's happening, right? Nowhere is it interesting, though. Yes, it was. So here's the scenario we've got now, people, and this is where our database starts to get ugly. So we've got router A, and router A is now learning about, of course, the loopback here on router 4, and he's learning about these routes in OSPF domain 2 through redistribution. So he's seeing some of these routes as type he's going to see them as type 5s advertised from him this way and this way. Right? Show, oh man, it is storming here in Florida again. Show IP OSPF database. Yeah, so router 3 now is learning, well, he's going to learn all these as external. Basically, everything over here on domain 2 is going to be learned as external. We got our 44.1. Let's just see if we have reachability. Which we don't. Ping. Okay, we can ping inside of our area. Okay, 192.168.4.1. But we cannot ping 44.1. Okay, why is that? He sees 33. Oh, that's the link state ID. That's the router ID. I need to be careful when I'm glancing this. It doesn't look like he is advertising. Let's see if router 1 sees it. Show IP route. Okay, he sees it. Look at that. He sees it as external. That's right. It should be that way. But look at, okay, so this is the problem we've got. Here's the problem we've got, right? Rad Puppy, man, I love the name. Good to see you, my friend. Good to have you here, Rad Puppy. So yeah, think about this from router A. All right, so I've got actually, let's jump down here. I've got 192.168.44.1, and it's being redistributed as an external route. That external route, which is an LSA type 5, is being sent to router A. And router A sees, okay, that, you know, he has a link to go that way, but he also sees router B, remember, he's redistributing everything from route process 2 to route process 1. So it's also being flooded here and received by router A so that he sees, I think he should see 2 external routes. Oh, I missed some. Sorry, guys. Man, I missed a bunch of stuff. Sorry I haven't been around much. Been super busy with work and trying to pack up the apartment for the big move. I'll be more active once I move. I know you will, man. Hey, this plus that is my fellow, like, Gary V follower. So I know you're gonna be hustling, man. That's what we do. Schumer 32. Don't know. That looks like, is that Russian? Cyrillic of some type? Yeah, Rat Puppy says quit slacking. I'm taking JNCI. Yeah, I've heard about that. I've seen that on Twitter, this plus that, man. I wish you the best. So you've got less than a week. And that's awesome, dude. I mean, you got your CCNA. It wasn't that long ago. And now you're knocking on the door of the JNCIA. So, dude, all for it, man. We know you're not slacking. So, good job. Very good job. And Bashy Message is like, Russ would always say, them pesky router IDs in Ospf. Yes. Wrap up. We do it, big buddy. Very Russian. Good stuff, guys. So this is what we're seeing here. As a matter of fact, if I do on router 1, show IP Ospf, let's say 2. Well, actually, if I do show IP, see, that's the thing. If I do show me process 2, database external, I'm going to see 192.168.44.1. If I do show IP OSPF process 1 external, I'm also going to see 192.168.44.1. So due to the fact that we have 2 domains, we have no way to really distinguish these external routes, because when you get down to 2 different OSPF domains, it comes down to the administrative distance, right? Which they're going to be the same. So if I look here, show IP OSPF, no, show IP route 192.168.44.1. Look at that. See, it has, I can get there via 192.168.4.1. So that's the router, right? I can go through the link on that router, or I can go through router 2. And I think what's happening here is we have equal cost multipathing. And if we go one way, probably when it gets to router 2, he's going to see 2 different ways. So let's say we forward this packet to router 2. We forward one this way, and we forward the next one this way. Router B may get it and say, oh, my shortest path is actually, I can go this way or I can go this way. So he might send it back this way. And half of our packets are going to do this, right? So how do we solve this? You know, we've come down to this crazy design team meeting. The big boss has said, this is how we're going to do it. We got to redistribute between 2 processes. So as it says here, when you redistribute between multiple processes, you use AD in order to prefer one over the other. Because OSPF route preferences apply only when they're the same process, right? So to distinguish them, we got to play with AD. However, this is not enough for a proper operation network, as explained later in this section. So we could do this. So we could say every external route that we learn from this process is going to be higher than the normal process. That would seem to work. But it's saying it won't. So consider network N in domain 1 where it will be known. Because the AD of external routes has been increased, router A and B will choose Ospf process 1 to reach network N, which we want, right? In a more general way, all networks internal domain 1 will be reached through domain 1. All networks internal domain 2 will reach through domain 2. Other routers in each domain pick up the closest ASBR or the shortest path through one of the ASBRs if metro type 1 is used. If there are prefixes external to both domains, the same problem will still occur because the administrative distance for these external routes is the same in both processes. If you make the AD for external processes different, it will not resolve the problem. Router C advertise. I think that's what we're seeing now. This prefix gets through router A and B into domain 2. With each of the routers, therefore N will be external in both domains. In order to have proper information, the AD of external needs to be different for the two processes so that one domain is preferred over the other. Assume that AD for domain 1 is set lower than domain 2. Now, if router D, ASBR, right, advertises M into domain 2, then this prefix is redistributed by router A and B into domain 1 and will reach each of the routers. Thus, M will be external in both domains, and because of AD is lower for domain 1, M will be reachable via domain 1. Router A redistributes M into domain 1. External M will reach router B. Because the AD of domain 1 is lower, router A will install B through domain 1 and will set the max age as previous originating LSA into domain 1. Because M has set the max age to domain 2, router A, router B will install M through domain 2 and therefore redistribute M in domain 2. This cycle continues. And the way to fix it is to have domain 2 prefix reachable via domain 2. The solution is to set administrative distance based on prefix. Oh my gosh. All right. So we get some churn in here because A is going to say, hey, you know what? He's going to tell B the best way to get to M is through domain 1 because domain 1 has a lower AD. And then what happens is because M is set to max age in domain 2, router A will install M through domain 2. Oh, because of the age out. Okay, so at some point, this will age out. And then he will prefer through domain 2. And then that will age out. And then he'll prefer, this will get redistributed again into domain 1. That will age out and then it'll get redistributed through domain 2. So we've got churn there. Interesting. You want one domain to back up the other domain in case one domain is unreachable. Okay. This is if you're trying to do, so this use case here is you just want to use shortest path. Basically, you want to do the best path, right? Always. You always want to have the best path. For this one, you basically want one domain to essentially be dormant. It says network operation with network failure. So you basically want this guy to just sit here and not be used unless we get some sort of link failure here, for example, right? So we want router A, unless of course it's M, we want router A to always use OSPF domain 1 to reach router B, to reach router C, always. But if we get a link failure here, then we obviously want this to be ready and available to use. Router A can send this out this link to router B to get to router C, right? That makes sense. And in this case, for example, because router A has lost connectivity network in, that's exactly what we're saying. Now router still use router B, yes. You see there's a race condition that could appear from one domain to the other. In events 1, 4, and 7, router A generates external N in domain 2. Events 2 and 5, router A withdraws a prefix. Problem occurs because the routes learned through one domain are redistributed back into the same domain. Ah, yes. Yeah, that's an issue also with, I've seen this issue with BGP route reflectors where, you know, the route reflector is only going to advertise a single path. And you could have a backdoor where all of a sudden another sort of spoke learns a better route through another protocol, and it withdraws the BGP route and sends that to the route reflector. Then the route reflector withdraws that route and gets an advertisement from another spoke, and then it reflects that to the first spoke, and you could get some also sort of oscillation there as well. This section shows how to prevent a route that belongs to the domain for redistribution back to the same domain in order to avoid routing loops. Okay. So this is, I guess, the most guaranteed way to prevent loops in this mutual redistribution between Ospf domain scenarios. The previous section shows how to routing loops created previously learned from one domain and redistribute back to the same. You can prevent a route that belongs to domain 1 that is learned from the remote router over domain 2 from being installed in the routing table. Therefore, the router will not redistribute these routes back to domain 1. Okay. In order to do this, enter the distance 255, router ID, inverse mask, access list command. This command tells the router to deny all the prefixes that are received by a remote router with a specified router ID and the match ACL. You know, I forgot about this because when I was talking earlier, remember we made some notes about what the limitations of filtering Lsas in Ospf. There really is no way to filter intra-area routes. Inter-area routes, you have a way using the LSA Type 3 filtering feature, and external routes really cannot filter in the same process. I think this is a workaround you could actually use in a single process, single Ospf domain, at least for external routes. You could sort of poison the distance on them. That is one way to filter. They kind of left that out, but this is exactly what we're going to be doing here. In Figure 6, Router A uses the access list 1 command in order to match all routes to domain 1, and use the distance 255 command or process 1 in order to deny routes received from Router B that match. Okay. The connected interface of Router B should be excluded from the ACL. Okay. Access list 1. So let's see. Router A, we're going to do this here. Redistribute OSPF2 subnet and then distance 255. Router B 0.0.0.02. And that's access list 2. It denies any route received from router B that belongs to domain 1 because, oh, okay. I'm not sure I get this. The previous section shows a routing loop is created if the prefix learned from one domain and redistributed back to the same domain. Yes, we demonstrated that. Because redistribution occurs from a routing table, you can prevent a route that belongs to domain 1 and that is learned from the remote router over domain 2, remote router. from being installed in the routing table. Therefore, the router will not redistribute those routes back to domain 1. Okay, that does take away our failover, though. I think. I'm pretty sure that takes away our failover. We'll do this. I mean, we'll configure, but I think, like, basically what it's saying is whatever routes I have here in domain 1 on router A, I'm going to filter them. I'm going to give them a distance 255 when they're coming in from domain 2. Right? Which is fine. That avoids routing loops, but it does take away our failover. But I guess you can't have it all, right? All right, so let's do an access list for this. And where did my config go? I had a configuration somewhere. So many windows. There he is. So we're going to say here on router 1, we're going to do this on router 1. Access list 1, and what we're going to do here. Matches the router in domain 2. I wish they would show me the actual example. Like, what does this mean, router B? I was wondering, okay, that's the route ID. Thank you, Red Puppy. Okay, I was wondering about that. Okay, so we're going to want to do access 1 matches the router in domain 2. Okay, this says matches the router. This says matches the route. And it says the same thing over here. So I think what it's saying is distance 255, the router ID. Okay. Yeah, why would it say router here? That should be, I think that's a typo, right? Yeah, this will match the router ID. This matches a router ID here, right? But the access list is a routes. Yeah, exactly. But it says router here. Just one little typo, guys. You know, sometimes that's all it would take to really confuse somebody. And I'm calling that a typo. They probably did copy, paste, whoever's editing this, and they just went back and changed router A to router B. That's probably what happened here. Ugh. Okay. So we're going to say access list 1. Now, what routes do we not want to learn from router B? We don't want to learn 10.1.1.0. And we don't want to learn... Oh, it does say we want to exclude the router N, right? Oh, the connected interface of router B in domain 1 should be excluded from the ACL. Yeah, I think the loops here, the problem is what's on router C. So this is what's looping. So we're going to exclude that, which that would be actually 192.168.3.0 and 192.168.33.0. So that's access list. That's going to be access list 2. And then access list 1, because that's what we're redistributing into process 1, is going to be 4.0 and 44.0. Okay, and then router Ospf 1, distance 255. Let's look at these router IDs. I believe I specified that. Show IP Ospf. Interesting. Show IP Ospf 1. Okay, interesting. So when it's coming from domain 2, the router ID is different. It's kind of a mess, isn't it? Probably should have made those the same. Yeah, I really want to hurt myself, don't I? Yeah, when it's coming from domain 2, that's the router ID. Okay, so we're going to want to do this after. And then Ospf 2 is going to be the reverse, essentially. And it's going to be access list. Let me make sure I have these right here. This is going to be 1. Yeah, this is from domain 2. And this is from redistributing from domain 1, which is this list. All right. I think that's it, folks. Let's try it. Okay, didn't like something. Oh yeah, my access list is all messed up. Access list 1, yeah. Permit. We want to do a permit here. Let's just do. We need to do an extended, really. Yeah, access list 101. No, IP access list extended 101. And we want to say permit. Okay, permit IP. Yeah. Is this what we want to do here? Yeah, prefix range with ACLs gets super sloppy. It does. Yeah, you're right. I think it. Yeah, we need to do, but I want to do multiple. So I just do access list 1 permit. All right, this is what I need to do, right? Access list 1 permit. I just need 2 statements. Okay, let's try that. Hyphen. Okay. Don't forget to update your mask on your distance command. 2 needs to be 255, 255. Ah, yes, yes. Were you talking about the distance? Well, I think the distance is... Yeah, it's a wild card, it looks like. Interesting, right? So access list 2 permit this. Then this, and then router Ospf, and this is going to be 1, and that's going to be 2. Let's see, guys, see if this works. Clear IP Ospf 1 process. Clear IP Ospf 2 process. I probably should wait to do that. Let's see, is the second wildcard mask of each of your ACLs is 32. Are you trying to match only the subnet ID? Oh, you're talking about on the access lists? Yes. So I'm trying to match only the prefixes coming from router 2 this way that are these 2 prefixes. So I've got a loopback 1 and a loopback 2. It did say that I needed to not exclude this link, which would basically be this shared segment, right? So if we look, for example, on router 2, no, don't do that. No. Show IP route OSPF. Yeah, like we've got 3.0. Oh, that's a /32, isn't it? That's also /32, but it'll still filter it out, right? Yeah, so he's going to learn these from domain 1, redistribute them into domain 2, and we want router 1 to filter those out. Show IP. So let's see what happened. Show IP route OSPF. All right, he's learning this from router 3. And he is still learning this from 10.1.2.2, so that did not seem to work. Well, actually, what's the distance? Yeah, we should be filtering this one out because it should have a distance of 255. What am I missing here? Whoa, my lights just flickered. Hope I stay on here, folks. If you're trying to filter 33, you need to change the second line of address to have the subnet ID end in .1. You're right. Thank you. Good catch, Rad Puppy. So true. No wonder, right? Because I'm not advertising 33.0/32, right? Good call, my friend. So let's just make it, let's do no access list 1. It won't let me do that, will it? Oh, it does. Okay. That's only on extended, right? So then we're going to say access list 1 permit. We're going to go ahead and filter out oh, you know what? I might have these backwards. This is domain 2. This is domain 1. Yeah, that's the problem. This should be 2. And this should be 1. And we need to change these. Access list 1 permit. 4.1. Let's just do this. So that we know exactly what we're trying to achieve here. Okay. Then we're going to say no distance. And we're going to fix this. Yeah, we do not want to redistribute these. No, I had that right. Had that right. Okay, now I've gotten this lost here. Let's see what I have configured. Show run section Ospf. Intriguing one, isn't it, guys? All right, 1 and 2 is what I have. But that may be right. Let me double check that. So router Ospf 1, I'm going to redistribute from domain 2. And the routes I don't want to see coming from domain 2 are these. Yeah, that's right. Okay. I think we've got it. So let's do no access list 2. And we're going to put these in. And we're going to do this. All right. Need a drink after that. Okay, let's go over here and fix, well, we think we fixed it. Let's take a look here again. Clear IP Ospf 1 process. I'm just not sure if everything is going to flush out correctly until we fix router 2 as well. But let's just see. Show IP. Well, let's give it a minute. In the meantime, I'm going to come over here and fix router 2. And we're going to do something very similar here. And we are going to say, did we do anything in router 2 yet? Maybe we didn't. Yeah, we haven't done anything, but let's go ahead and put our configuration here. So, same thing, 4.1, 44.1, router Ospf 1 distance. What is the router ID that he's showing? Okay, at least this one's consistent. 10.1.1.1. And we don't need to do any no's here. Actually, yeah, I should do that. 10.1.1.1. Let's double check this. Okay, access 1 permit 4, and this is domain 2. Router Ospf 1, distance 255 from this router from domain 2. Yeah, I keep doubting myself on this. No, that's right. We want to filter from domain 1 going back into domain 1. That's right. Okay, good. All right, so let's check in on router 1 over here. Show IP route 10.1.44.1. Uh-oh. 192.168, sorry. Yeah, 192.168. Okay, we still have 33. We are still learning from 10.1.2.2. And that's the one that we're trying to filter out. Yeah, it does not seem to be working. Redistribute Ospf 1, some distance 0.01. Routes are not installed. The configuration works probably in case where both routers lose connectivity to the network. However, because the prefixes are denied, domains cannot back up each other. Yeah, that's what we already stated. You must explicitly list all the prefixes of each domain in an ACL. Maintenance of such an ACL can be very difficult. Yes, indeed. Okay, so we must be doing something wrong here. 192.168.33.1. Yeah, that should be filtered. Show run section Ospf. All right, I think I want to make these router IDs the same. That can't be helping. So we're going to make this 10.1.1.1. Oh, router OSPF2, router ID. Oh, we have to use different router IDs. (10.1.1.1) and 10.1.2.1. So this would be on router 2. Oh, I bet I have this wrong. Distance 255 10.1.2. Wait, let's see what router it's learning it from. Show IP OSPF. Database external. One nine two one six eight 3.1. Advertising router 10.1.2.1. This is process 1. (10.1.2.2). Okay. Okay, that may be the issue here. Yeah, this is routing process number 1. This is the one we want to filter out. We want to filter out 192.163.1 from 10.1.2.2. Okay, that's what we're doing. Let's do show IP protocols. Ospf 1, router ID 10.1.1.1, routing for networks. Routing information sources. Redistributing external routes from Ospf 2. Distance 10.1.2.2, wildcard mask. Distance 255, access list 2. Interesting. Distance to provide router and the access list number. Well, I think the thing is, folks, I'm not trying to, I get the concept. I must have something wrong in the configuration. But by actually typing it out, I've accomplished my mission here, right? This is how you would basically want to filter those routes. But as we said, when you do, you do lose your backup paths, right? So that makes sense. As we don't have a real example here, we don't have all the configuration listed out. We're not sure what I'm missing, so I'm just going to have to move on, which is fine. I'm at peace with that. All right, so that is one method of doing redistribution. Let's talk about filter routes based on tags. And generally, what you see a lot of times in mutual redistribution scenarios, what are two of the ways that you control or prevent routing loops? It's the same. Whether it's Ospf and EIGRP with mutual redistribution, looks like it's pretty much the same with Ospf and different process redistribution. It's distance and tags, right? With the exception, it looks like the Ospf to Ospf, that what you need to do, you can't necessarily solve all the problems just by making one higher than the other. To truly prevent routing loops, especially of external Lsas, you need to filter via the distance 255, which is understandable. But here we have filter routes based on tags. This allows you to filter routes based on the tag to prevent the redistribution of routes from one domain back into the same domain. Router can tag a route that belongs to the main what is redistributing, and you can filter those routes to a remote router based on the same tag. Okay. We've all seen this before. I'm not going to lab all of this. But that makes perfect sense, right? This configuration works properly in cases where both routers lose connectivity to the network. However, because prefixes are denied, the domains cannot back up each other. Understood. All right, use the match internal keyword. When you're redistributing from a domain, you can use match internal keyword to redistribute only the internal routes that belong to one domain into another domain. Okay. Yeah, that makes sense. You do that, have a similar function with BGP, right? Specifying Ospf into BGP. Subnet match internal. This looks like the best way to do it, really. This configuration works properly in cases where both routers lose connectivity to the network. One domain could back up the other domain. If there are already external prefixes in either of the domains, then those prefixes will not be redistributed in other domains because only internal. Also, there's no control over external, and the external will be blocked. Okay, I like this one the best. Let's go ahead and do this one. show run section Ospf. Let's take this out. Obviously I failed at getting this right, but I'm okay. I'm okay with that. So we're gonna say here router OSPF1, router OSPF2. Actually, you want to do okay, and then we're going to go back up router OSPF1, redistribute OSPF2 subnets internal. What other options do we have here? Ooh, I don't see internal here. Is that a code thing? Banner, is there a link to this in Discord? Is this that? There probably is not, but there you go, my friend. You got it. Oh, subnet match internal. Okay. What are our options here? Okay, this is cool. So we got external, internal, NSA external control over this, just like we do with like BGP redistributing OSPF. We can do internal, we can do external, we can do actually on the drill sheet I have listed these out. Anyway, match internal. Router OSPF1, no. Router OSPF2, redistribute OSPF1, subnet match internal. Okay, sweet. I like that. This seems to be the cleanest. Router OSPF1, redistribute OSPF2, subnets match internal. Router OSPF2, redistribute OSPF1, subnets match internal. Let's do a show run section OSPF. Oh, what happened there? Is that the default? It did not remove that. Okay, let's remove it. Redistribute OSPF2 subnet match internal. Interesting. So you all saw what I did, right? I mean, everybody saw me do that. Do show run section. Okay, that's weird, guys. Yeah, so I typed a more specific command here, and it ignored it. Everybody saw that, right? I'm not going nuts. I'm not going crazy, not yet. So I guess I need to take this out, then do redistribute OSPF2 subnet match internal. Weird. It's Halloween in August, people. Then redistribute OSPF1 subnets match internal. Weird. Okay. Do the same over here. Finish cleaning up. Router OSPF2. No. It's just like it ignored the command. Like even though I'm telling you to do something different, you're choosing not to, like a little child. Clear IP OSPF1 proc. Yes. Clear IP OSPF2 proc. Yes. Same over here. Clear IP OSPF1 proc. Clear IP OSPF2 proc. Weird, right? Okay, match internal. Good. Good, good, good. Yeah, there is a limitation here, though, as it's saying if there are already external prefixes. So let's say I learn Yeah, here's the problem with this, right? Here's the problem with this topology. Let me go to my... Seems like each one of these has a scenario where it will not absolutely just work. You have to sort of pick... And here's what I mean. So let's say router... let's say router 1 has another interface here. And it's connected via... Well, that probably won't work, so... Let me read this again. If there are already external prefixes in either of the domains, then those prefixes will not be redistributed to other domains. Okay. Only internals are redistributed. Also, there's no control over external prefixes, and all external prefixes will be blocked. Okay, so what happens here is router 4 is not going to learn the loopback up here to router 3 because it will not be sent this way, right? That's where this fails. It seemed ideal there for a minute, but let's just verify that now. Show IP route Ospf. Okay, it still has it. It hasn't aged out, I don't think. Clear IP. No? Here's OE2. I think 3.1 has not aged out. Maybe clear IP Ospf process 1. Let's just see. Let's go to router 3 as well. Should be the same. Clear IP Ospf 1 process. Yes. Yeah, each one of these has its pros and cons, doesn't it? There's no one size fits all. Still no adjacency. Well, I wonder what time it is for the folks here in the chat. You all are up here late Sunday. Man, that's great. This is not exactly what I expected to see here. Show IP Ospf neighbor. Oh, it's still DR other. Show IP route Ospf. Yeah, I guess it's going to prefer those connected. So he's not really going to learn anything through Ospf now. But that's what we expect. We lose the external route. And all that other junk, remember, because it was seeing a lot of these as externals as well. Because they're being redistributed. Let's look at router 3. Huh, yeah, they're not seeing anything. They're not learning those loopbacks anymore. So that could be a problem there, right? All right, the other option here it mentions is prefix-based filtering. Yeah, the solution above Rad Puppy, I agree. Up here, It's this one, without network failure. You could do it this way, but you would still have potentially some issues with external routes. Yeah, you can use AD for one process over another because Ospf route preferences apply only when the same. However, this is not enough for proper operation in the network. There still may be some churn with prefixes external to both domains. You'd have the timeout issue, and you'd have some oscillation here, but this one will work with AD, right? Actually, no, this one. Suboptimal routing might occur, yeah. What I mentioned here is to set distances per prefix. If there are prefixes external to both domains that come from other redistribution points, right? So you have a redistribution point over here. The same problem will still occur because the AD for those external routes is the same in both processes. Make the AD for external processes different, it will not resolve the problem. And I didn't read through all this, but basically saying router A redistributes M. Because AD of domain 1 is lower, router A will install M through domain 1 and will set to max age its previous original LSA into domain 1. Because M has been set to max age in domain 2, router A will install M through domain 2 and therefore will redistribute M into domain 2, same as event 1. The cycle continues, and the way to fix is to have domain 2 prefix reachable via domain 2. However, if the AD is set lower for domain 2, then the same problem will occur for domain 1 and for prefix N. The solution is to set AD based on prefix. And I think this is the, shall we say, the tightest solution, right? At least that's how I'm interpreting it, as long as each know the proper. Yeah. We do have this solution here. I haven't read through this yet. Prefix-based filtering, that's what I'm used to, right? We're all used to this. When you redistribute a domain, prefix can be matched. It gets an ACL to avoid redistribution prefixes. A little cleaner than the AD solution, right? This configured in case where both routers lose connectivity to the network. One domain could back up the other domain. You must explicitly list all the prefixes of each domain in an ACL. Maintenance such an ACL can be very difficult. Another solution is to tag prefixes during distribution and then filter the corresponding tags. Yeah, match tags. So then you have prefix-based filtering and prefix-based administrative distance. There's a need for prefix-based administrative distance when there are external prefixes originated by other ASBRs in each domain. The next example topology, ASBR 1 and 2 redistribute networks X and Y, domain 1 and 2, respectively. This example uses an ACL in order to match all the prefixes, internal and external, that belong to a domain, and it uses the distance command in order to increase administrative distance of prefixes that, do not initially belong to the corresponding domain. So as we see here, ASBR, we've got an ASBR over here, and we've got an ASBR over here. So basically what we're doing is we're writing out every prefix in the network. And that could become very cumbersome, right? The distance 200 is 0.2555. Command sets the administrator. Well, that's not too bad. Of all prefixes that belong to domain 2 to 200, therefore routers A and B use domain 1 to reach prefixes that belong to domain 1. You must explicitly list all the external prefixes of each domain in the ACL. Yeah, maintenance can be, the ACL can be very difficult, to say the least. I mean, in these examples, folks, we've got a very small number of networks, right? Very small number of networks. But when you get into larger domains where you've got a couple hundred prefixes, especially external, right? Because you've got a lot of external networks. Let's say you're in a core, right? What if you're in a core network or a data center network? And I mean, you're just talking, that would be, but it can be done. That's the cleanest way to do it, apparently. So in summary, folks, wrap this up. When there's more than one redistribution point between OSPF domains, routing loops can easily occur. In order to prevent routing loops, prefixes that belong to a domain should not be distributed back to the same domain. Also, the AD of the OSPF process should be set correctly. These 5 methods have been proposed in this document: using distance 255, filter based on tags, using match internal, using prefix-based filtering during redistribution, using prefix-based filtering, prefix-based administrative distance. The first 2 solutions prevent the routes that belong to domain from being installed in the routing table, which prevents the redistribution back to the same domain. But because they're denied, the domains cannot back up each other. You can use the last 3 solutions to back up a domain with another domain if needed. However, you should note these caveats. The match internal solution is not allowed to have control over prefixes, and all external prefixes will be blocked. In other words, there are external prefixes from other ASBRs, then those LSAs will not be redistributed, right? These prefix-based filtering solution allows the domain to back up another domain. However, backup only works correctly when there are no external routes from the other ASBR. And then this final one, the use prefix-based filtering and prefix-based AD, is the only solution that allows the domain to back up another in the presence of external routes from ASBR. So it looks like this is the one, the hardest one. This document repeatedly refers to the use of one domain to back up another domain. It should be noted that backup means that should router A lose its connection to part of the domain through a given domain, then it could use the other domain in order to correctly route those destinations. Or if a domain is partitioned because prefixes are not redistributed back to the original domain, then the other domain cannot be backed up. Cannot back up. Right. Whew, this is a complicated one, folks. But I think what I've learned from this, a couple of things. One, that it's very similar to solutions you might use for mutual redistribution between OSPF, like an OSPF domain, and another administrative domain of another routing protocol, like RIP or EIGRP. There are some similarities. Where we run into problems with OSPF in OSPF is the fact that we have the same administrative distance. When you have OSPF and RIP, for example, OSPF will always be preferred. When you have OSPF and EIGRP, you're going to prefer OSPF because it has 110 versus the external route of EIGRP, 170. So even there, though, you have to also often resort to some of these tools like route tags. Route tags has usually been effective, and distance, right? So yeah, that's one thing I've learned. I thought there were going to be some other like magic unicorn dust that you had to use with OSPF, but in reality, it looks like a lot of the techniques are very similar to some of the others. You just have to take a few more precautions with OSPF to distinguish the routes coming from one area into another, right? So good stuff. I hope that was helpful, folks, and thank you for hanging out with me, man. We're going about 2 hours here on this thing, so which is good. I've had some good Ospf review, good mutual distribution review, and thanks for hanging out, folks. A lot of smart people here in the chat. Appreciate it. We're going to get back on tomorrow night. I'm not sure what I'm working on tomorrow night. I may look at EIGRP to EIGRP. Yeah, I think that's probably my next one. So we'll probably play with that tonight. I don't know if there's any specific articles for that, but maybe we'll do a little labbing too. Thanks for hanging out, folks. I'm going to say good night and get ready to relax, get ready for tomorrow. Going to try to hit the gym early tomorrow morning, get back into the routine. I've been traveling, so looking forward to that. Thank you for all the support, folks, in the channel. I've got some new follows. Again, sorry for the... Okay, yeah, sorry. I got to work on the Streamlabs thing, get these announcements going. But yeah, thanks so much, folks, for hanging out. Appreciate it. And we shall see you back here. Send you all the good bits until we see each other again back here in Land Tamber Stream. Y'all have a good night.